So therefore, okay, if you substitute this one, if you substitute this one with B delta S, what will happen is we have B here, and this B is the same as B in the opposite member. So therefore, B, if you transfer this B towards here, this will become square. Okay. Then, so therefore, we have in the left side we have only delta B over delta T, and your B becomes B squared over R. Okay. So take note that if you apply, take note in the opposite side, we come up with what? We come up with delta B over delta T. But there's a missing line. So in this case, okay, well, let's try to do it this way. So substituting delta S, okay, delta B, I hope I can do it, okay, divided by delta S, but delta S is V, okay, multiplied by delta T. Okay, this is it. This one. Substitute it here. Okay. Then, in the right side, we come up with B squared, okay, or B over R. Okay, this is B over R. B over R. Okay. Now, this B is the same as this one. Okay. So, therefore, leaving delta T, so what we have now is the change in velocity, okay, the change in velocity over delta T. I hope I can do it. Something was missing on my presentation. Maybe it was deleted. Okay. So then, okay, hopefully I can survive. B is B square. Okay. Closer to the finish line. Okay. Okay. That's it. So this is not the result because this B was transferred here to become B squared. And this is delta B over delta T. And this is B squared over R. Okay. Now, analyze this one. Remember, what is this? Change in velocity per time interval. Okay. Now, if we take a limit of this, delta B over delta T, as delta T approaches 0. So, the result becomes now the instantaneous acceleration. We call this as centripetal acceleration. So therefore, this one is equivalent to the centripetal acceleration. So the centripetal acceleration is equal to B squared over R. Okay, this is it. I survived. So therefore, what is centripetal acceleration? The centripetal acceleration is the square of velocity. Take note, what's velocity? This is the velocity of the particle moves around the curve and divided by its radius. And radius is inversely proportional, which means that if you have a greater radius, you have a smaller centripetal acceleration. Okay? But if you have greater magnitude of velocity, you have a greater acceleration because it is directly proportional. Okay, so then, okay, change to arrow. Okay, then, okay, now take note. This is the relationship between the acceleration centripetal to the velocity. And we understand it is directly proportional to the square, the velocity, and inversely proportional to r. Now, take note, Newton's law, in the second law, that if you multiply the mass and acceleration, the result is the net external force. Now take note that we have this acceleration. So if our acceleration is centripetal acceleration multiplied by the moving mass is here, this one, the result is a kind of force, and we call this as centripetal force. Now the centripetal force, this is the reason why that the object can able to move the turn to the cord. No? So why is it that the particle turn around the cord? The reason is because of that force. We call it as centripetal force. A centripetal force is a force that tend to move towards the circle, meaning it maintains the radius. The radius is the same. So therefore, the requirement in order to make a turn is we need the force, and that force is the centripetal force. Now, if we substitute the centripetal force acceleration here, the result is mv squared over r. Okay? So in this formula, this is now the important formula, no? Which means that the requirement of an object to make a turn in a curve with radius r, okay, the amount of force is the product of the mass of the moving object times the square of that velocity divided by the radius is the centripetal force. Okay? So, this is it. This is our formula. Okay, where if C is a centripetal force, or we call sometimes call this a radial because it is towards the radius, and the unit should be Newton. E sub C is the centripetal, or sometimes called this as radial acceleration, and the unit must be meter per second squared. Okay, then R is the radius of the curve, and it should be meter, and m is mass of the moving particle. And V, okay, I forgot to have the V. V, take note this V. This V is called as, okay, another struggle. This is the linear velocity. Take note, linear. Because in a curve, there are two velocities, okay? V is called as the linear velocity. This is linear velocity or linear speed. Okay, speed is the magnitude of velocity. Okay, velocity. Oh yes, and the unit is meter per seconds. This is it. Okay, so V is what? The linear velocity. There are two velocities. Remember, linear velocity is the velocity of changing its magnitude. It is the magnitude of that per second. But we have the another velocity, the so-called angular velocity. So the angular velocity is the time rate of changing its direction, and it's the terms of the angle. So we have the another velocity later. Okay. So let's continue. Uh, Presenter, winter, arrow. Okay. So then, okay, these are the important formulas. If we are talking about, what is it? Dynamics on a circular, uniform circular motion, these are the formulas to be used. A sub C is B squared over R, F C is MB squared over R. Okay? Now, we will engage the angular velocity. Why? Because angular velocity in the symbol omega is important in the curve. Why? Because we are talking about the change, how much angle be changed for every time, every hour. Okay? With time, when the time rates of the angle. So we call that as the angular velocity. Now, what is the relationship with angular velocity to the linear velocity? Which means that what if the linear velocity is not given? Is not given. And you are given an angular velocity. How will you convert this one in such that we can produce the linear velocity? Or in short, what is the relationship of the angular velocity to the linear velocity and the radius of the circle? So to answer that question is, we have to use the sector of a circle. A sector of a circle, it has an arc length, it has a radius, and it has a central angle. Okay, now, if this angle is in radian, okay, by principle of geometry again, this arc length can be calculated. How? Your arc length is just the same as the product of the radius and the angle. Okay? It is just the product of these two, provided that this angle should be in a unit of radian. So therefore, this is the formula. So, meaning you can simply multiply r to theta, provided that this is in radian measured. So therefore, it is the arc length. If this is degree, Then convert this to degree. Degree to region. Now remember, one region is what? 180 degrees is pi region, because the 360 is 2 pi region. So therefore, you can convert that to region. Okay, so therefore, we will use this one, which means that this is region measure. So if we evaluate this with time, we will take the time rate of this. We will analyze this with respect to time. So dividing this by t, dividing this by t. Now take note that s over t in mechanics is velocity. This is the linear velocity. Now when you divide this r theta with time, at any time r does not change because r is always constant. The only way that changes its magnitude is the angle. The angle is keep on increasing as time goes on. So therefore, we have the time rate of the angle. So theta per time, this is the angular velocity or angular speed. So therefore, this is linear velocity, okay? This is linear velocity, r is still r, and this is theta over t is the angular velocity. So this is the relation, okay? Or we can reverse the orientation, because linear velocity is omega r. Omega means the angular velocity, which is equivalent to the change in angle per time. Change in angle per time. So take note that this theta is radian. Okay, so therefore, if you use this formula, this should be radian per seconds. Okay, so therefore, in the problem, if given the angular velocity or angular speed, is you have to substitute this linear velocity here. So what will happen if you substitute this to the velocity? So then, the result is this one. Square of the angular velocity and the square of r. Then take note, we have r in the denominator. We can cancel 1r. So leaving m omega square over r. So therefore, this is the centripetal force in terms of the angular velocity. These are important velocity. Okay? Now remember that when you are in the curve, then you will be encountering this angular velocity. Angular velocity is sometimes given as RPM in a unit. RPM is a unit of angular velocity. Okay, sometimes. RPM means the revolution per minute. So all you need to do is to convert that. Take note that if you are in SI, the angular velocity should be in radian per seconds. Okay, and this is kilogram, and this is meter. So therefore, the resulting unit must be Newton. So therefore, if the given is RPM, convert that to radian per seconds. Now remember one revolution is 2 pi. Okay, 2 pi radian. So convert the one rev to 2 pi. Then the hours should be converted to seconds. So RP, a minute to seconds. 1 minute 60 seconds. So therefore, you can convert. Before going to use the formula, make sure that the unit are consistent. Okay. So reminders. Okay. Your omega, lowercase omega is the angular velocity. The unit should be, okay, this is very important, radian per seconds. Okay, so now let's have this example on application problem on riding on a flat curve. So imagine that we are riding on a curve. The object is, the car is moving around the curve. We are riding this car. Okay, so therefore we are moving around the curve also. So take note that when the car passes through the curve, the driver should what? Slows down. Okay? Especially when this road are wet, so very slippery. So therefore, in order to make a turn, what will be your speed? You have to reduce it. Okay? Because if you don't reduce your velocity, and this area is very wet, then what will be the result? The car will cannot make a turn. It will move in a straight line in your initial velocity. Cannot make the turn. Okay? So why? Because there is no friction. So therefore, the reason why the particle moves around the curve is because of the friction. If the friction in the road and your wheel is a very, very small friction, then you cannot make the turn. So this problem says that we have the flat road curve or curve road. The radius is 230 meters. So therefore, this is a 230 meters. By the way, this is an aerial view. Okay, with a coefficient of static friction. Okay, this is the friction between the car and the road, car tire, the road. The coefficient is mu is, this is 0.96. We use mu is because this is actually perpendicular to the direction of the road. So therefore, it must be at rest at that point. But it is not at rest in along the road, which means that it won't slide because of that friction. Okay. Now, the question is, if this is the coefficient of friction, 0.96. Remember, coefficient of friction is the what? The ratio between the static friction divided by the normal of the normal contact. So therefore, it is depends upon the material in contact. There are coefficient of friction that has smaller in friction coefficient, so therefore, then it has a small friction. But this one, we have 96. This is rough surface because the coefficient of friction cannot be equal to 1. Cannot be equal to 1. It is always less than 1. There is no coefficient of friction greater than 1 because if it happens, so therefore, it doesn't exist in nature if your coefficient of static friction is greater than 1. Why? Because if you have a greater than 1, it means to say that your friction is greater than the normal. Friction is greater than normal. It won't happen. The friction is always less than the normal force. Normal force is the force between contact, and it is always against and perpendicular. Okay, so therefore the relationship between the angle between the normal and the friction should be 90 degrees because the friction is along the plane while the normal is always against and perpendicular to the plane. Okay, so therefore, what's the question? The question is, what is the maximum speed, call it as Bmax, at which the driver can take the turn without sliding? So therefore, if that velocity cannot make a turn, all you need to do is to reduce it. The question is, how much velocity is required for that in order to make a turn with the condition of this friction, 0.96, and also the condition of the radius. Take note, if you have a radius of 230, okay, the maximum speed will differ if this is 200 or less than 200. So therefore, it varies also with radius. If you have greater radius, then what will happen? Inversely proportional. So therefore, you need a smaller force. Meaning, the requirement, take note that the centripetal force is the requirement of that force in order to make a turn. And it is the friction that measures your requirement. Okay? So therefore, uh, so therefore, all you need to do is to analyze the car in a plan. This is an aerial view. Okay? This is an aerial view. Now we need to show where is the direction of the weight. So therefore, you have to see the view in a front view mode. So if this is now in a front view mode, this is now the car, no, facing towards you. Okay, this is the road. This is a flat road. Okay, because there is no angle. This is horizontal, and this is the car tire. Okay, so they are facing in front of the car. So the best thing to do in order to answer the problem is to use the frontal view. Okay, why? Because we can now observe or see the weight of this object because the weight is a function of that problem. Okay, so all you need to do is to construct the free body diagram of this car. Okay, what are the forces acting on this? Now take note that the first important factors that to consider in order to answer this problem is you have to identify where is the center of the circle. So in this case, look at this one. You are facing here in front of the arrow, and this is the radius. So therefore, the center of the circle is towards the right, towards right, at your right side. Okay. So therefore, the circle is actually a kind of horizontal circle. So your r is directly towards the right. So therefore, your centripetal acceleration, take note, it is always radial. It should be towards the radius. So therefore, the acceleration of this car is going to this axis, along x-axis. Okay, so therefore, this is the direction of acceleration. Now, Newton's law says that whatever acceleration direction will be the same direction of the force, centripetal force. So therefore, we already have the idea on where the net external force of this, which is the centripetal force of this car moving in a curve. So therefore, it tends to move towards the center of the circle, and this is the axis. Okay. Now, next move is to identify all the what are the forces on the car. Okay, what are the forces? Okay, we have weight is always present because of the mass. It is the mass times gravity. Then since there is a contact between the tire and the car, so there must be an upward force, normal force. We call this as the force against the or force between the surface and the car moving. Okay, what else? What else is friction? Now the question is, where is the direction of friction? Now take note nga, we did not analyze the object moving towards us or towards you. Okay? We analyze in 2D only. We have the x towards your right or towards your left, and we have the y upward or down in your location. So therefore, the question is, where is the friction? Where is the friction? Okay, the answer is, now take note, the tendency of this car is to move away, di ba? Look at the aerial view. If your force cannot hold, then this object will move away from the center. So therefore, this object, because the center is towards positive x, the object will tend to move along negative x. Okay? Negative x, not negative y, because the car won't move down and won't move up. It is the same. So therefore, force along y must be 0. But force along x could not be equal to 0. So again, where is the direction of friction? The answer is, what is friction? Friction is an opposing force. Okay? It tends to move in opposite direction of the movement. So the tendency of this car is to move away. Away means it is negative x. So therefore, friction must be in opposite direction. It must be in the direction of the x-axis. Okay? So careful of your direction of your friction. Now take note, friction is mu times the normal, or the mu is times the normal force. So normal force is this one. It is the force in the contact. So therefore, if we ask how many forces are there in the car, there are only 3. We have the weight, the normal, and the friction, which is directed towards the positive x. Okay, so therefore, if you sum up all forces along y, take note, the sum should be 0. Okay, so in that case, we can solve the problem. The y should be 0. Okay, why is it 0? Because no way that the car moves down and no way that the car moves up. It is always maintained at that level. So the sum should be 0. Now, if we sum up forces along x, is that equal to 0? The answer is no. Okay, because if x is also 0, then what happens is the object is at rest. We understand that this won't be in a rest position. This is moving towards you. Okay, towards you. But our problem is talking about that the car can make the turn without sliding the curb. So therefore, there must be a force along x. And looking at this figure, if you sum up all force along x, the force is positive friction. Therefore, the friction is towards the positive x in our notation. Okay, so therefore, in that case, again, summing up all force along y, then equal to 0, we can solve for normal. It is mg. So therefore, take note, they must be the same. So whatever weight will be your normal. Now, the purpose of calculating n is to substitute this n towards the friction. Okay? So later on, we will use that. So leave it as normal. Okay? Then, leave it as equation 1. Okay? Summing up all forces along x. This time, it is not equal to 0. Okay? Why? Because when you look at the primary diagram, again, the friction is tend to move towards the positive x-axis. So therefore, summing up all forces, the only value is F, and that is friction. Now, take note, because this is the force towards x, so therefore, it should be equal to what? The centripetal force or the net external force along x. So therefore, this is the net external force also. So, take note that from the formula we derived before, this is the formula for the uniform circular motion in terms of velocity, linear, and this is in terms of angular velocity. So therefore, the formula says that F is mv squared over r. So we can utilize this one. Take note that our external force is F. So therefore, we can replace this with F. Okay? Because there is only one force along the axis, and that is F. So therefore, F must be equal also to mv squared over r. Okay, look at this resulting equation. F is the friction, m is the moving mass, v is the linear velocity. So this is the velocity at this curve while moving. Take note that the question is, what is the maximum velocity? Okay, that velocity becomes maximum only if we use this coefficient of static friction and this r. No? Now we will substitute friction. Friction is mu times n. Friction is mu times. So therefore substitute it. Mu n. Mu is. Now normal is mg. So do it. Replace n with mg. So therefore the resulting is mu is mg. So take note that this mass is the same as mass. So meaning we can cancel it out. Leaving what? Mu g over or equal to v squared over r. Okay, then we are to solve for the velocity. So taking the product in square. So we have this maximum velocity. Why maximum velocity? Because we will be using the given the condition of the road. Actual condition is 0.96 is the coefficient friction, and this is the Earth's gravitational acceleration times the radius of 240. So therefore, we can now calculate the velocity by substituting the values. Okay, everything are consistent. So therefore, your maximum velocity that the driver can make the turn, it requires only 46.54 meter per seconds. This is the answer to the problem. Okay, so therefore, what's the meaning of this? The meaning of 46.54 meter per seconds, this is the maximum. So the question is, if you drive the car instead of having 46.54, you make it 47. What do you think will happen? Okay? The resulting effect is you cannot make the turn. Why? Because this is the maximum. Okay? You can drive below this number. So that's why the reason why drivers will have to slow down in a curve. Why? Because it requires a maximum velocity depending on the status of the frictional force. Because take note, the friction is responsible. Look at this one. The friction is the force that allows you to make the turn. Okay? So therefore, if the condition of the road of the friction is very minimal, then you have also a very minimal velocity requirement. Okay? So You are safe if you are moving below the 46.54, but you are not safe above this velocity. That's why we call this as maximum velocity. Suppose you want to move not because your 46.54 is not enough. You want to move, let us say, a velocity of 50. Okay? So the question is, how much friction needed? What must be the coefficient of friction if you want to move with a velocity of 50? You can do it. Okay? All you need to do is use this equation. Okay? Substitute the 50 here, convert that to meter per seconds, or look at the unit, then reduce. If the radius is the same, then do it. Then this is 9.81, substitute. Then b square over gr. Then b square over gr, that is the coefficient of friction. Okay, so therefore you can do what you want on the equation. You have to use your algebra, manipulating the equations, then you can do it. So all you need to do is to analyze clearly the problem. Now remember that this formula, the mu g is equal to b squared over r. This is only applicable for what? For the flat curve road. For the flat curve only. You cannot use this to other. Now, this is not only for the car. No? You can use, for example, let's say, uh, desk, rotating desk. Then you want to analyze, when you place a coin on top of it, you want to analyze how much angular velocity requires in order to stay the coin at rest. Okay, in the problem, you are talking about angular velocity, then you have to use this formula, the m omega square over r. Okay, so I think we have already solved the problem. So this is again the maximum velocity. Now, in order to practice, no, so try this problem. Practice problem number one. How large must be the coefficient of friction? This is the problem that, okay, given the radius. Remember, no? Look at the formula. This is the relationship. This is a kind of flat rod. This is a kind of flat rod. You are given with the radius and you are given with the velocity. So you are asked to calculate how much is the coefficient of friction. Okay? So therefore, you have to do the conversion. Convert this to meter per second for consistency, or convert this to kilometer. You can do it. Then take note that coefficient of friction is uh, dimensionless. There is no dimension of the coefficient of friction. So therefore, if everything are consistent, then can go because there is no unit. Now, problem number 2 is this is talking about the merry-go-round. So it is a horizontal circle again. But there is no friction. Take note of that. But you are asked to solve for a centripetal acceleration. So centripetal acceleration is a sub c. Take note, b squared over r. So you have this 1.5, okay, and you have this radius. So therefore, then very easy. Then you are asked to solve for the net horizontal force. This is centripetal force. You can use this formula. Okay. In number 3, level track was radius. Given the radius level track, meaning this is a flat road curve. You are asked the coefficient again, the friction. Given the radius, very simple. So all you need to do is to practice solving. Okay. Remember this. This is very important formula. No, this is not only the you can start here, then go for other depending on the problem. Okay, so you have to memorize this, that this is centripetal, linear velocity, this is angular velocity, radius. Okay, so there are next problem is what will happen? Okay, what will happen if you want to move around a curve in a high speed velocity? So the solution to that is to bank the curve. You are observe that when national roads, the road was banked. Okay, so the question is, how much angle is required to bank the road? in order that the car can make a turn with a specified velocity. Okay? The question is, if you increase the bank angle, will it be safe for a 100 kilometers per hour speed? Okay? So those are questions that we need to answer next video. So, I think that's all. Thank you for listening.